The Thevenin equivalent circuit. Thevenin's theorem was derived in 1853 by Hermann von Helmholtz and independently theorized 30 years later in 1883 by Leon Charles Thevenin, an electrical engineer in France. Thevenin's equivalent circuit is a circuit consisting of a single voltage source with a series resistance connected to a load. Here demonstrated is a complex circuit consisting of a voltage supply, 3 resistors, and a load resistor. The aim of the Thevenin equivalent circuit is to reduce the circuit into a simpler circuit consisting of a singular voltage supply, series resistor, and load resistor, as seen here. This circuit will behave identically to the complex circuit shown above. For this example, we will create a complex circuit, further calculating the Thevenin voltage and resistance for the circuit, and simplify it to a Thevenin equivalent circuit. To calculate Thevenin voltage, first remove the load resistor from the circuit and calculate the voltage across this gap. As it is now an open circuit, voltage will no longer flow through R3. We can now use the voltage divider rule to calculate the Thevenin voltage. The Thevenin voltage is equal to the voltage supply multiplied by R2 on R1 plus R2. Subbing in our values, we receive a Thevenin voltage of 7.5. We can now calculate the Thevenin resistance. To do this, we need to remove the voltage supply by shorting the circuit across it. Doing this, we can redraw the circuit to show R1 in parallel with R2, calculating the Thevenin resistance where the load resistor has been removed. To calculate the Thevenin resistance, we can find the resistance of R1 and R2 in parallel, and add this to R3 as they are in series. This will give R1 multiplied by R2 over R1 plus R2 plus R3. Subbing in our values gives 6.75 ohms. As we now know the Thevenin voltage and Thevenin resistance for this complex circuit, we can now include them in the generic Thevenin equivalent circuit. This will give a Thevenin voltage of 7.5 volts, a Thevenin resistance of 6.75 ohms, and the load resistor as seen in the complex circuit.